For decades, we believed we had conquered infections. A tiny cut was no longer a death sentence. Antibiotics became our miracle shield. But while we were celebrating, the microbes were studying us, evolving in our hospitals, our farms, even our bodies. A century after Fleming's discovery, the war beneath our skin has reignited. A handful of superbugs are outpacing our drugs. Just in a couple of minutes, you'll understand how this silent rebellion could spark the next global pandemic. Just imagine that beneath every cell lies a city that never sleeps, a living metropolis called Bacterion. Here, trillions of citizens work in fragile harmony, trading nutrients, passing signals, keeping you alive. For a time, antibiotics ruled these streets like guardians, crushing invaders once called upon. But every wall we built reshaped the life within. Deep in the alleys of Bacterion, a forbidden exchange begins. A strand of code changes hands. Cooperation slowly turned to corruption. Each antibiotic victory quietly pushed evolution one step further. When the antibiotics fell, most bacteria perished, but a few adapted, small fragile bacterial cells that somehow survived the antibiotic storm. They looked fragile, but they carried a secret weapon known as mutation. These were the first survivors, the ancestors of a new era. Each round of mutation is like a trial of survival. Each treatment killed the weak and crowned the resistant. Soon these survivors weren't exceptions. They turned into a mighty and invisible alliance. And the drugs that once obliterated them passed through like mist. We call them superbugs. They resist penicillin, slip past cephalosporins. Some even outmaneuver carbapenems, once seen as our last resort shield. What began in Bacterion is now our reality. Hospitals, once sanctuaries of healing, have become frontline battlefields. The World Health Organization now warns we are edging toward a post-antibiotic era where minor infections can kill again. Nearly 5 million deaths each year are linked to drug-resistant bacteria, not from new plagues, but from old killers we thought we'd buried. So how did we allow this microbial alliance to happen? We're about to step inside this war properly. If you value deep science storytelling, tap subscribe and like the video so you don't miss what comes next. Let's head back to Bacterion. When an antibiotic enters your body, it's like launching precision strikes into Bacterion. Some blast open bacterial walls, some jam protein factories, others corrupt DNA blueprints so cells can't divide. Every dose is designed to hit something vital. But bacteria are ancient fighters. With billions of years of training, they mutate, reshaping the target so antibiotics can't latch on. Some release enzymes, tiny molecular scissors that slice drugs apart. Others install molecular pumps, ejecting antibiotics before they do damage. With each failed kill shot, the survivors grow smarter. And they don't keep the victories to themselves. Microbes trade genes like secrets in the dark through plasmids in a process scientists call horizontal gene transfer. Think of plasmids as glowing upgrade cards passed hand to hand. One resistant bacterium can hand out those cards to its neighbors, and an entire colony can wake up fully armed by the next day. And unfortunately, we helped them, prescribing antibiotics for viral infections, stopping courses halfway, feeding drugs to farm animals just to grow faster. Each misuse was evolution's rehearsal. Now resistant genes show up in rivers, soil, even Antarctic ice. But here is a positive twist. On the other side of this war, our defenses are evolving too. Across the world, scientists are designing next-generation antibiotics, using artificial intelligence to search chemical spaces far beyond anything we've tried before. In 2020, an AI model scanned millions of molecules and flagged one with powerful antibacterial potential, Halicin. It wasn't born from classic trial and error, but through pattern recognition, a new kind of weapon forged from data. Others are turning to ancient allies, bacteriophages, viruses that hunt bacteria with surgical precision. They can adapt alongside their targets, a living, evolving sniper squad in this microscopic war, an arms race where, for now, we still choose the rules. Also, new fronts are opening, antimicrobial peptides that punch holes in bacterial defenses, CRISPR tools to disarm resistance genes at the source, microbiome therapies that fortify our friendly microbes to keep invaders in check. The light returns, but most of these strategies are still in their early stages. But none of it works without stewardship. Use antibiotics only when they're truly needed. Finish the course. Demand policies that stop routine use in agriculture. Every careless dose is a training drill for superbugs. Each wise choice slows evolution's clock, buying time for science and for us. We discovered antibiotics through genius. Now we keep them through discipline. Every resistant microbe is a message. This world was never ours alone. We share it with invisible nations of life, all obeying the same brutal rules of survival. In the survival game, victory has never gone to the loudest attacker, but to those who learn and adapt the fastest. Our drugs will fail, some strategies will break, but our strength has never been in a single weapon. The war is far from over, but neither are we. Hope you enjoyed the video and will join us again next week. But till then, stay med curious, stay healthy. See you soon.